Chapter 18 and 19 term structure and credit risk will cover in this. This is again a September 2013 paper. So write down the stochastic differential equation for the short rate R in the Vastric model during defining any notation used. So first doing this. So if you see here, it's there. The stochastic differential equation for the short rate R is dRt is equals to backslash of alpha backslash of mu minus R underscore t dt plus backslash of sigma d v underscore t. Okay, where v is the standard Brownian motion, and sigma is the volatility, and mu is the drift parameters. Okay, drift parameter. Next is part 2, which is a theory part, which you can see lists the desirable and undesirable features of this model for the term structure of interest rates. This part I am not doing. Shear theory. Let's do part 3. Part 3 says me solve the stochastic differential equation from your answer to part 1. Comment on the statistical properties of RT. So here first let St is equals to e to the power backslash of alpha t RT. Okay, so this is there. Then this is all t equals to dst is equals to d of e to the power alpha t RT okay, and then so d of e to the power alpha into t, and ERT is separate. This is d is just inside this RT plus e to the power alpha t into dRT. Okay, so backslash alpha e to the power alpha t alpha e to the power alpha t dt into RT plus e to the power alpha t into backslash of alpha mu minus RT dt plus sigma d zt. This is equals to, if I open brackets, alpha e to the power alpha t RT and alpha e to the power alpha into RT gets cancelled. We left with backslash of alpha backslash of mu e to the power backslash of alpha t dt and plus sigma dzt and alpha plus sigma dzt, and there's a e to the power alpha t also. E to the power alpha. Relabeling the parameters. U. Relabeling the time parameter as u. And integrating both sides from t to capital T. So alt equals to backslash int underscore t to the power t dsu is come out of the integration is equal to backslash int underscore t to the power capital T alpha mu e to the power. I'll just copy, I'm not writing anything, just replace dt with u. Okay, come out of the integration backslash sigma backslash int underscore t to the power t and e to the power alpha t dzt. Again replace this with u, e to the power alpha u and dzu. Okay, so alt equals to s of u underscore t to the power capital T is equals to backslash mu e to the power backslash of alpha u is the underscore t to the power t plus backslash of sigma slash int underscore t to the power t e to the power backslash of alpha u dzu. So alt equals to s of capital T minus s of capital T is equals to backslash of mu and e to the power backslash of capital of alpha t minus e to alpha t minus e to the power backslash of alpha t brackets close plus backslash of sigma backslash int underscore t to the power t e to the power backslash of alpha u and dz underscore u. Okay, or you could have just written dzu like this also, doesn't matter. Okay, finally we substitute to get equations in terms of RT and rearrange to get alt equals to e to the power alpha t RT minus e to the power small alpha t RT is equals to mu into just plus sigma into alpha. This or alt equals to RT is equals to RT e to the power minus alpha into t minus t plus backslash of mu 1 minus e to the power minus alpha e to the power t minus t plus sigma t to t e to the power alpha u dzu. So this is how we solve the differential equation, Vasicek's standard differential equation, and then comment on the statistical properties of RT. So if you, this is again a theory part, I'm not writing the theory part, the comment part. Okay, so this is there. Now next is question number 10, which we'll do. Describe the model for pricing a bond for to default risk. Is model pricing the bond. Again, if you see, this is a description question. Describe a model, which is again a theory question. Models assume and all this thing. Next is a very highly geared company, XYZ PLC, has issued 0 coupon bonds payable in 4 years time. The debt is a nominal 120 million. Give expressions for the value of debt in 4 years time today, adopting a Black-Scholes model for the value of XYZ PLC. The current gross value of PLC is 180 million. Continuously compounded risk-free rate is 2%, and the continuously compounded credit spread on the bond is 4 point. Calculate the price of the bond, estimate the nearest one, and determine the risk neutral probability. So first we need to find the expressions. So let's do the expressions first. So question 2 for this is equals to expressions. So let dt be the value of the debt at time t, and let ft be the value of the firm as a whole at time t. At time 4, the bondholders receive the lower of 120 million and F4, that is D4 is equals to minimum of 120 comma F4. Okay, this can be rewritten as D4 is equals to F4 minus max of F4 minus 120 comma 0. Okay, where the final term can be treated as the payoff on a European call option on the firm's assets. With maturity at time 4 and strike price equal to 120 million. Using the Black-Scholes formula for the value of such an option, D0 is equals to F0 minus F0 backslash phi of D1 minus 120 e to the power minus 4r backslash phi of D2 and so this had to be in brackets. Okay, So therefore this is equals to f0 into 1 minus phi of d underscore 1 plus 120 e to the power minus 4r backslash phi of d underscore 2. So that is equals to f0 backslash of phi of minus of d underscore 1 plus 120 this. Okay, where d1 and d2 are their usual meanings. Okay, now next third is the price of the secure bond today. So alt equals to d0 is equal to 120 e to the power minus of 0.02 e to the power minus of 0.02 plus 0.045 into 4 brackets close, which is equals to 92.526. Okay, and now part 4, which is equals to let ET be the implied volatility. We have to calculate the volatility. So let ET be the implied volatility at time t. The equity value is the difference between the firm's total value and the value of debt. So at time 0 we have A0 is equals to F0 minus D0 so this is equals to 180 minus 92.526, which is equals to 87.474. Okay, now E0 in terms of Black-Scholes is equals to A0 is equals to F0 into phi D1. So we had this, right? I just copy this, Control C. F0 phi of D1 plus 120 e to the power minus 120 e to the power minus 4 at phi of D2. So this is equals to 180 into backslash of phi of D underscore 1 minus 120 e to the power minus 0.08 backslash phi of D underscore 2. So if the volatility is sigma, is equals to 40%, 10 alt equals to D underscore 1 is equals to, in brackets, ln of F not divided by L plus R plus half sigma square into T brackets close divided by backslash of sigma sigma backslash of sqrt of t. Okay, so this is equals to, this is equals to ln of 180 divided by 120, then r is equals to my 0.02, then half into sigma square we have assumed to be 0.4 square, and t is supposed to be 4. Similarly here also 0.4 into 4, root over of 4. So this calculates to 1.0068, and then alt equals to d2 is then equals to d underscore 1 minus backslash of sigma backslash of sqrt of t. So this is equals to 1.0068 minus 0.4 backslash of sqrt of 4. So this is equals to 0.2068. Okay, and once you have this values, we can put in the values of our E naught. So therefore E naught is equals to 180 backslash phi of 1.0068 minus 120 e to the power minus of 0.02 into 4 backslash phi of 0.2068. Okay, so volatility, this is and once you solve this is equals to 87.28, and for volatility for sigma is equals to, if you check for sigma is equals to 41%, do the same calculations which we have done earlier, you will see E naught is equals to 180 into backslash phi of 1.0020 minus of 120 e to the power minus 0.02 into 4, or backslash of phi of 0.1820, which is equals to 88.14. Now if you see, this is a further away than previous, so the employed value is 40%. Okay, so you have to match according to your value over here, which we had calculated 87.474, and you see for the first calculation this is almost close and the other one is not so close, so obviously 40% is our implied volatility. And the last one is determine the implied risk neutral probability is, so part 5, the probability of xyz defaulting is 1 minus probability of call option being exercised. So that is equals to 1 minus phi of d underscore 2, which is equals to 1 minus 0.5819, which is equals to 0.4181. So 42% is the probability. So that's it about these two chapters also.